Today we are going to do section 8.3 on page 801, inverse functions for sine, cosine, and tangent. Now the inverse functions, as you remember from inverse functions in the past, is the opposite of what we've been doing. For example, let's look at this chart here. Okay, from here we can see the sine of 30 degrees is equal to sine of 30 degrees is equal to 1 over 2, okay, opposite divided by hypotenuse. So the inverse function of this thing is called arc sine, A-R-C sine. And arc sine of 1/2 means what angle, okay, what's the angle that will give the sine value of 1/2? And that angle will be 30 degrees, or we can call it pi over 6, being that pi is 180. So that is the inverse function for sine is called the arc sine. So generally, arc sine is when you are given some kind of a dimension, such as I have a triangle here, and this side is say a number. Let's say this is 5, and this is 3, and then what is the not that side, because that wouldn't be the whatever. And that's fine. Let's say the angle, the length measurement is this is 5 and this is 3. And the question is, how much is the angle? Well, then we look at it and we say, what is the relationship of 5, 3, and the angle? Let's call the angle theta. Okay, so the relationship would be that will be tangent theta, right? Because tangent is opposite over adjacent. So 5 over 3 will be equal to tangent theta, and that's their relationship. So we can write it down as tangent theta equals to 5 over 3, which means that to figure out what theta is, we just need to, then theta is equal to the inverse tangent, that is arc tangent, A-R-C-T-A-N, okay, arctan of 5 over 3. And this is actually a specific button on the calculator. If you punch in arctan 5 over 3, that will give you how big the angle is. And so that is the whole point of the inverse function, is now that we know how to use the trigonometric functions and figure out what the sine, cosine, and tangent are, then now we can use them to use the arc function, the inverse functions, to figure out what the angles are. Okay, that is the purpose of inverse functions. So let's look at the page 801 on top. There are certain things that you should consider to take a look at. That is, the sine function is for the arc sine, we are restricting it from minus pi over 2 to pi over 2 to define the inverse sine function. And the cosine function, we're restricting it is range going from 0 to pi. And tangent is restricted from minus pi over 2 to pi over 2. I'm talking about the range. Because to do inverse functions, as we know, the sine, cosine, tangent are not one-to-one functions. You know, they repeat themselves. Like this part repeats itself, and so there are a lot of answers to it. So to design the inverse function, we have to restrict it to a part where that is where inverse function will make sense. So sine is restricted to design the inverse function. Sine is restricted from minus pi over 2 to pi over 2, and cosine is restricted from 0 to pi. And tangent is restricted from minus pi over 2 to pi over 2. Okay, so let's look at the next page, okay, to see what the inverse functions graph look like. The following page 802, we have on top, there shows the book is showing you both sine x and the inverse function. Now I just told you that the inverse function is called arc sine or arc cosine or arc tangent. There is another way to write it though. The inverse function is also written with a -1 on top, like you see here. That means the exact same thing as this, okay? And normally when we write down x to the power, say, x to the power -1, that means 1 over x, right? And that is not the case here, okay? So this, when you see the sine inverse, that's an exception to the rule. That is, this does not mean 1 over anything. This means the inverse function, the arcsine. That's it. That's all it means. So the arcsine function, also sine inverse of x, is the tangerine or whatever greenish color here. That is, it goes down here and then go up there. Okay, pay careful attention. It goes down here. That is across the middle dotted line. And the black line is actually the sine function. And the reason the book draws it this way is to show you that the sine function and the arcsine function are mirror images of each other, as all inverse functions are. Okay? Anytime you want to draw an inverse function, you just draw the mirror image across the y equal to x line. That is the 45-degree line, the red thing. Okay, so that is how you do any inverse function, not just this one. So anyway, next, that is the sine function. Now similarly, the cosine function, look down a little bit in the same page, where we see the inverse cosine function again is this greenish line that goes up there. And is the mirror image of the cosine x, just this part though. Okay, the inverse cosine looks looks like that, and then lastly, the inverse tangent function. It again is drawing it this way, although the inverse tangent function doesn't actually stop. The inverse tangent function, you see the arrow here? It goes this way. It goes this way all along an asymptote, and the same as here. Okay, the inverse tangent function will keep going along that direction. But the sine and cosine don't. The sine and cosine inverse functions, the inverse sine, you see it stopped right there. See the dot there? And then it also stops right up there. That's it. That's all the farther it goes. And similar to the inverse cosine, it goes from there to here. And that's all the farther it's ever going to go. But inverse tangent, however, goes on forever on both sides. The shape of the graph is not that exciting, actually. And by that I mean useful, but it's interesting to, it's worth mentioning. Okay, so let's turn to the next page, where let's look at example 1. It says that if sine of 5 pi over 12 is 0.96, etc., what is inverse? Write something that has inverse sign with it. Well, that just means inverse sine inverse of 0.96, etc. is 5 pi over 12. That's all that means, and that's what the example says. So there's that. And so next, let's look at example 2. Now, example 2, okay, let me write this stuff down. Okay, now example 2 on page 803, we're looking at part A, where we're supposed to calculate what is sine inverse of 1/2. That is, let's look at this thing right here. We have 1/2 right here, opposite divided by hypotenuse. Okay, what angle opposite and hypotenuse in this relationship? That will be the angle 30, or pi over 6. So the answer, the angle is pi over 6. In other words, sine of pi over 6 equals to 1/2, and that is the answer. Okay, and the next we have sine inverse of some negative thing. And by now, well, I really don't want to mess with the negative numbers. And so let's pull out a good old calculator and crank it out that way. What are we doing? We're trying to calculate sine inverse of negative square root of 2 over 2. So let's do that. Now the sine inverse in calculator will be pushing shift of sine. If you look carefully on top of the calculator, you'll see the sine inverse symbol right on it. Okay, yeah. So, but anyway, so let's do to do this problem, we'll do sine inverse negative square root of 2 divided by 2. Nope, that's bad. I need to get out of the square root. There, divide by 2. See, that's much better. And then let's figure out what that is. That's minus a quarter pi. Okay, that is the answer. Let's see, is that right? Minus pi over 4. That's right. And so the next problem, cosine inverse of negative square root of 3 over 2. So let's do that. Cosine inverse shift cosine negative square root of 3, and get out the square root, divided by 2 is 5/6 or 5/6 pi. That is, let me see, let's see, the answer is 5 pi over 6. That's right. And finally, part D, we want to do tangent inverse of just 1. So we'll do that without the calculator. So what angle it gives 1? Now look at these two triangles. And that's why I told you that these two triangles are important, because they're good for assigning homework. See, and the tangents is the opposite over adjacent. Okay, now let's consider this. Opposite over adjacent is 1, right? Because it's 1 over 1 is 1. And what angle whose opposite over adjacent is 1? That would be the 45 degrees, or pi over 4. So for part D, the answer should be pi over 4. And let's look at part D, or you can just type it into the calculator. And yeah, pi over 4, that's it. Next, example 3. The book wants us to calculate inverse sine of 0.97. Let's do that then. 0.97 is example 3. What was it? Sine inverse of 0.97. All right, that equals to 1.325. That's radian. Yep, it is. Okay, so that's 1.325. That's like maybe 75 degrees or something. Doesn't matter. Yeah, actually it is. Wow, I just guessed. And anyway, the book says in example 3 is 1.32, which is about 75.93 degrees. All right. And so that's that. That's example 3. So next, let's look at example 4, where we consider some kind of a thing. Okay, now let me write down example 4. So problem 4, this is on page, well, it's the following page. I forgot to write down the page number. It is on page 805, but anyways, it's after problem 3. I mean example 4. Anyway, here's example 4 on page 805. And we're supposed to figure out what the angle is. Now to figure out what the angle is, we're giving some numbers. How are these numbers related to the angle is the question, okay? Now this side, this here is adjacent to the angle, right? And this side is the hypotenuse of the triangle. So this is adjacent over hypotenuse, which if we look at our list here, adjacent over hypotenuse is the cosine. In other words, then cosine of theta, the cosine of this angle is equal to 9 over 12, which means theta then is, we can crank out theta by doing cosine inverse of 9 over 12, which is what we're going to do right this moment. Okay, let's do cosine inverse of 9 over 12. All right, so let's clear that. Cosine inverse of 9 over 12. Let's see, is this clear enough? I hope so. Well, I haven't typed anything yet. Anyway, shift cosine inverse, all right, and then 9 divided by 12 equals 0.72. That's in radian. That's about, I don't know, 35 or so degrees, I think. Let's see, 41, okay? I'm not that far off. 0.72, that is what I said, and that is correct. So that's example 4. And example 4 is all the word problems in this section. Is that sort of thing. You just, they ask you to lean a ladder somewhere, you know, so many feet away from the base of the building, and then what's the angle of the ladder, that sort of question. And it will all be exactly the same as example 4. Or same or very similar. And then anyway, so let's look at the next thing we can look at is for example, we're going to skip the rest of the examples, okay? Because they want you to calculate the sine of sine inverse or something, which I don't see why. I mean, what's the point of doing that? And if you once you figure out the angle, if you need to calculate the tangent of it, you can go ahead and do so. So we're going to skip the rest of the examples, because they are a waste of time. And so let's go clear to the end of this section, which is page 810, and here's your homework. So for homework in this section, please do problems 9, 11, 13, 15, 19, 21, 23, 53, and 61, and that's it. Yeah. So that should be good enough. Okay. The problems, you can do them by hand, or you can do them just with a calculator. Either one is fine. And generally speaking, if you're told to do some kind of negative things, then the answers is sometimes negative, sometimes isn't. It's easier to just use the calculator because it has to do with which domain you want or something. So then, but otherwise, just if you understand what this means, that's all that matters. Okay, that is, once we know the ratio, sometimes we want to know the ratio, we have the angle, and we want to know the ratio of the sides. But other times we have the ratio, we have the sides, and we need to know what the angle is. So digging out the angle is what the inverse trigonometric functions are for. And so please do your homework, but I won't be talking about them because they're all very short. So I don't think you will have trouble with them. Okay, so that will be the end of this section.